Thank you all for joining this virtual meeting. I have gathered you all so we can design an airspace system for the United States.
Why don't we just let each state set their own airspace rules?
To fly across the country, I would need to learn 15 different sets of rules.
Yeah, that definitely will not work. We need a national set of airspace rules.
Well, it doesn't make sense for the same rules to apply everywhere. Around my farm, there is way less air traffic than in busy cities.
The rules may vary between busy places and rural areas, but not state to state.
We need to provide reliable, all-weather service to our customers. We have equipment that allows us to navigate precisely even in the clouds. Controllers on the ground can keep track of where everyone is using radar. The controllers give each plane permission to proceed after making sure no other airplanes are in the airspace ahead.
Wait, no way. I just fly for fun. I don't want to ask some dude in a radar room somewhere for permission for everything.
If you don't get clearance from a controller, how do you avoid hitting other airplanes?
We look out the window, man. See and avoid.
Settle down. We can accommodate both of you. We can have two sets of rules, one called Instrument Flight Rules, or IFR, and another called Visual Flight Rules, or VFR.
Is some of the airspace going to be reserved for IFR traffic only?
You guys can have the airspace that's really high, like above 18,000 feet. We don't fly up there anyway.
We also need the airspace around really busy airports like our airline hubs.
How much airspace do you need around an airline hub?
About 30-mile radius should be enough.
No way. That would include a ton of airports besides the airline hub.
We don't need to have control of all airplanes all the way to the ground. We only need that for maybe 5 miles radius. Beyond that, it would be okay if we aren't talking to the pilots that are down low. And we don't need to talk to pilots that are above about 10,000 feet either.
How low would airplanes need to be for you to feel okay not talking to them?
The farther away they are from the main airport, the higher they could be. But I guess the answer might be different for each airport.
So, it sounds like you want a block of airspace with several different layers, like a wedding cake.
Yeah, except upside down. The bigger diameter layers would be on top.
Okay, do you VFR guys think you can live with that?
Well, I understand why a clearance from a controller would be necessary in that airspace. But I don't think we should be excluded from flying there if we talk to the controllers and follow the rules.
So is everyone okay with VFR pilots flying in that airspace as long as they follow some IFR-like rules?
They would also need to have the right type of equipment installed so that we can see their position and altitude.
I'm glad we have that settled. What about airports that are only sort of busy?
Around those airports, 10 miles would be enough. In fact, at airports that have a control tower but no radar service, the airspace could be even smaller.
What airspace do us VFR guys get to ourselves?
The radar systems that controllers use aren't usable for really low altitudes. So VFR pilots can have the airspace below 1,200 feet.
1,200 measly feet. That is hardly anything.
Excuse me, what was that comment?
Sorry, I thought I was muted.
It can't be 1,200 feet everywhere. I want to be able to fly IFR to all of the thousands of airports in the country, not just the ones with control towers. I can't land at an airport IFR if the airspace near the ground around that airport is only for VFR pilots.
Good point. We need to allow IFR down to the ground around airports with instrument approaches.
Actually, the instrument approaches require us to have good enough visibility before we go below a specified altitude. If that specified altitude is high enough, then 700 feet of VFR-only airspace would be okay.
Okay, that leaves the airspace between 1,200 feet and 18,000 feet, excluding those places around busy airports. I suspect that all of you folks want to have access to that airspace.
Sure do. That's a huge amount of airspace.
Of course I need to use that airspace. It would be impossible to fly to all of the places I want to fly to without spending most of my time in that airspace.
So VFR aircraft and IFR aircraft will need to coexist in that airspace.
VFR pilots agreed to follow many of the IFR rules when we fly close to busy airports. I think the IFR pilots should agree to follow VFR rules when they use this airspace over rural areas.
When we are flying in the clouds, we will need to rely on controllers for separation, but there shouldn't be any VFR aircraft in the clouds. I suppose when we are not in the clouds, we could agree to do the see and avoid thing.
This see and avoid concept will only work when the pilots can see each other from far enough away to recognize the potential collision and take action.
You're right. We can't have people flying under the VFR rules when there isn't enough visibility. How much visibility should be required?
That would depend on how fast the airplanes are flying. When we are flying at 500 miles per hour, 5 miles of visibility should be required.
Maybe you shouldn't fly so darn fast.
Our customers expect us to get them to their destinations quickly.
Since your airplanes cruise at high altitudes, a speed limit at lower altitudes wouldn't add that much to your travel times. Could you agree to a speed limit of 250 knots below 10,000 feet?
I guess we could live with that. So below 10,000 feet, a visibility requirement of 3 miles would be enough.
We can't agree to that speed limit. The military needs to be able to fly really fast at low altitudes.
How about if we set aside some areas for the military to do things like flying really fast at low altitude?
We could probably confine most of that type of activity to those areas, at least for training. We can't make any promises about what we would do to respond to an actual threat.
What about when we pop out of a cloud into clear air? If there is a VFR airplane flying right next to the cloud, we wouldn't be able to see each other in time for see and avoid to work.
Good point. We will need to make the VFR aircraft stay some distance from the clouds. How far away from the clouds do they need to be?
When we descend through a cloud, we typically descend at a rate of about 500 to 1,000 feet per minute. So 500 feet would be enough. But when we climb, our climb rates can be much more than that, so we should have 1,000 feet above the clouds.
How far do we need on the sides of clouds? Would that be 3 miles like the visibility requirement?
3 miles isn't practical. The gaps between clouds are rarely big enough for that. And the VFR aircraft wouldn't be flying toward the cloud. I could live with 2,000 feet.
2,000 feet wouldn't provide very much time to take evasive action.
There could be situations where 2,000 feet would be borderline. We should encourage VFR pilots to allow more clearance than that whenever practical and to minimize the time that they are flying around at the sides of clouds. But we will stick with that as the regulatory minimum clearance.
Those limits might be sufficient at low altitudes where airspeeds are less than 250 knots. But above 10,000 feet, the limits should be increased to 1,000 feet below, 1,000 feet above, and a mile horizontally.
We need to have some names for these different types of airspace. You know, something better than really busy and sort of busy. How about if we call them positive control areas, terminal control areas, terminal radar service areas, control zones, etc.?
People in other countries use the letters A through G to designate different classes of airspace. We should adopt that system.
But they have something called Class F airspace. We don't have anything like that in the U.S.
That's okay. We will just skip over F and go straight from E to G.
We should review what we decided for each class of airspace, one at a time.
I agree. Class Alpha is pretty simple. Only IFR above 18,000 feet.
Is that 18,000 feet pressure altitude or true altitude?
That's true altitude, what your altimeter says with a local pressure setting. However, once in Class Alpha, you should set the altimeter to 29.92 and report altitudes as flight levels. Now let's move on to Class Bravo, the upside-down wedding cake around really busy airports. Since the shapes vary, I have asked our chart person to share her screen and tell us how Class Bravo will be depicted in the sectional charts.
Okay, are you guys seeing my screen?
Yes, I am seeing it.
These solid blue lines indicate the boundaries of the Class Bravo airspace, or boundaries between regions that have different altitude limits. Inside each region, you will see something that looks like a fraction. The numbers on the top and bottom of the fraction indicate the altitude of the top and bottom of the Class Bravo airspace in hundreds of feet above sea level.
Everyone needs to get a clearance from a controller before entering the Class Bravo.
How do we know what frequency to use to contact the controller?
Those frequencies are listed in a table like this along the side of the sectional chart.
Do we need to have instrument ratings?
No. Although you are following rules that are similar to IFR rules, you don't need an instrument rating. Since you are not instrument rated, VFR flights need 3 miles of visibility, like most other places.
Do we need to stay the same distance from clouds as in other places?
No. Since the controllers are responsible for separation between aircraft, including VFR aircraft, The reason for needing those rules doesn't apply here. You just need to stay clear of the clouds.
We need to be able to see everyone in the system, including altitudes, so everyone needs to have a Mode C transponder and ADS-B out.
This magenta circle indicates where you need those pieces of equipment. It extends 30 miles from the main airport. The equipment is required within this region even if you are outside the Class Bravo or under the Class Bravo.
Let's move on to Class Charlie. This is the airspace around an airport that is busy enough to have radar service, but not busy enough for a Class Bravo. Chart person, can you show us what these look like on the sectional charts?
Sure. A Class Charlie is indicated by magenta lines like this. The altitude limits, in hundreds of feet above mean sea level, are indicated by fractions just like they are for Class Bravo, except in magenta. It is usually a 5 nautical mile inner ring and a 10 nautical mile outer ring. But there are some exceptions. The inner ring usually extends from the surface to 4,000 feet above the ground, and the outer ring usually extends from 1,200 feet to 4,000 feet.
For Class Charlie, we can be a little less formal than in Class Bravo. Instead of requiring the magic word clearance, airplanes can enter Class Charlie as soon as they have two-way radio communication with the approach controller.
How do we know when we have two-way radio communication?
If you call us and we answer with your tail number, then you have two-way radio communication. If we don't use your tail number, then it doesn't count.
So, do we find the frequency in that table on the side of the sectional like we did for Class Bravo?
That is one option. There is also a white box with a magenta outline somewhere near the Class Charlie that shows the frequency.
Another option would be to listen to the ATIS frequency shown in the airport data block. We usually say the approach control frequency on the recording. You should listen to that before calling us anyway.
The standard VFR visibility and cloud clearance rules apply.
Can you remind us what those are again?
Sure. The standard visibility requirement is 3 statute miles. The standard cloud clearance rules are 500 feet below, 1,000 feet above, and 2,000 feet horizontally. Those numbers will be the rule unless there is some special reason to use higher or lower numbers.
Do we need to install transponders and ADS-B?
Yes, you need that equipment inside the Class Charlie and above the Class Charlie. You don't need it to fly under the outer ring.
Before we move on to Class Delta, I'd like to mention flight following. VFR pilots can take advantage of controllers outside of Class Bravo and Class Charlie if they want to. Although it is not required, we will call out other traffic if we have time, and you will already be in contact with someone if you have a problem and need assistance.
Moving on, Class Delta is the airspace around airports that have a control tower but don't have radar service. Chart person, can you show us what that looks like on the sectional chart?
Sure. Class Delta is shown by a blue dotted circle like this.
You forgot to share your screen.
Oh, sorry. Is that better? Class Delta is generally 4 nautical miles in radius and extends from the surface to 2,500 feet above the ground. Sometimes there are some extensions to accommodate an instrument approach. The altitude of the top of the airspace, in hundreds of feet above sea level, is shown in a little box like this.
The frequency for the control tower is in the airport data block. You need to have two-way radio communication with the tower before entering Class Delta, the same as for Class Charlie.
What if we don't have a transponder or ADS-B out?
That equipment is to help us provide radar service. Since we are not providing radar service in Class Delta, you don't need that equipment.
What are the cloud clearance rules?
Maybe you weren't listening when I said that the standard VFR visibility rules and cloud clearance rules apply unless there is some reason to use different numbers. Nothing about Class Delta calls for different rules.
The exception to that would be a special VFR clearance. If the visibility is at least 1 mile, a controller can give a special VFR clearance. When operating on a special VFR clearance, the aircraft must stay clear of clouds.
These rules would be a lot easier to remember if there weren't so many exceptions.
That brings us to Class Echo. This is the airspace that VFR and IFR aircraft share. Controllers provide separation between IFR aircraft, but otherwise we rely on see and avoid. This airspace extends over the whole country up to 18,000 feet, where the Class Alpha begins.
The general rule is that a transponder and ADS-B is not required below 10,000 feet above sea level. However, as we discussed earlier, they are required above Class Bravo and Class Charlie airspace. That equipment is required to fly above 10,000 feet, with an exception for places that have very high terrain. Specifically, if you are less than 2,500 feet above the ground, you are not required to have the equipment even if you are above 10,000 feet above sea level.
Are you going to get mad at me if I ask again about the cloud clearance rules?
The standard rules apply below 10,000 feet MSL. Above 10,000 feet, the requirements increase to 5 miles of visibility, 1,000 feet below clouds, 1,000 feet above clouds, and 1 statute mile horizontally from clouds.
So that leaves Class Gulf airspace, that little slice barely off the ground.
That is the area that is just for VFR traffic, right? We won't encounter any IFR flights there?
IFR flights are allowed to be there, but the rules that IFR flights need to follow make it impractical for them to spend very much time in most Class G airspace. They may transition through Class G airspace after taking off, and they may spend a little time in Class G airspace on non-precision approaches. But the rules for VFR flights in Class G airspace are based on the idea that IFR flights are not likely to be popping out of the clouds.
So, this is one of those cases where the standard visibility and cloud clearance rules do not apply.
Yes, Class G is an exception to those rules. During the day, you only need 1 mile of visibility, and you only need to stay clear of the clouds. But at night, you still need to follow the standard visibility and cloud clearance rules.
Actually, there is an exception to the nighttime exception also. If you stay within the traffic pattern, you only need 1 mile of visibility. I have used that exception to refresh my night currency before starting an IFR flight with passengers.
Ugh, exceptions to the exceptions to the exceptions. These exceptions make the rules complicated.
Class G airspace goes up to 1,200 feet above the surface by default. The sectional chart depicts places where that is not true. We have already talked about places where Class Bravo, Class Charlie, or Class Delta airspace starts at the surface, so there would be no Class G in those places. There are also places where Class Echo starts at the surface. Those are depicted on the sectional charts by dashed magenta circles like this. These surround airports with precision approaches. The Class Echo surface area may have some extensions to contain the approach.
What about the area around non-precision approaches?
Around those airports, the Class G airspace only goes to 700 feet AGL. Those boundaries are shown with magenta shading like this.
We have been talking about the low Class G airspace that people across the country should all be familiar with. There is also some Class G airspace above 1,200 feet AGL. There used to be a lot of that in the western states, but there are only a couple areas like that left now.
Even though there's hardly any of that left, we all need to memorize the rules for it. So, what are the rules in High Class G?
For Class G airspace above 1,200 feet AGL, the VFR rules are the same as they are for Class Echo airspace with one exception. Below 10,000 feet, only 1 mile of visibility is required as opposed to the 3 miles that are required in Class Echo.
It figures that there would be some exception.
If the VFR rules are almost the same as Class Echo, then why not just make that airspace Class Echo?
Well, the rules are different for IFR flights. IFR flights do not need a clearance in this type of airspace.
ATC wouldn't give anyone a clearance in that airspace even if they asked for one.
Great. So now we have covered all of the different classes of airspace.
We aren't quite done yet. We still need to talk about special use airspace.
Good point. Special use airspace is set up to accommodate activities like military training that require restricting the operations of aircraft that aren't part of those activities.
We need some areas where any operation of non-participating aircraft is prohibited. Let's call those prohibited areas. We also need some other areas where we can impose restrictions on non-participating aircraft, but not completely prohibit them. We could call those restricted areas.
Those are not very creative names.
Prohibited areas and restricted areas are shown on the sectional chart using blue hatched borders. There is a table on the perimeter that shows the controlling agency for each restricted area. That is the agency that can give permission to operate in the area.
Warning areas are areas off the coast. Like the name implies, they are there to warn pilots that activities may happen in those areas that would be hazardous for non-participating aircraft. Military operations areas are airspace where the military has received waivers to do things that wouldn't normally be allowed, like aerobatics, mock air combat, intercepts, and low-altitude, high-speed flights. VFR flights are allowed there, but the pilot needs to use extreme caution.
Here's an example of what a warning area looks like on a sectional chart. MOAs are shown on the charts using red hatched borders. The tables on the perimeter of sectional charts also show the controlling agency and typical operating hours for each MOA. You can also get information about whether an MOA is active by asking a flight service station.
The controller can coordinate with these agencies for IFR flights. If you have an IFR clearance through a restricted area or an MOA, the controller has done that.
How should we handle events that need some protected airspace only temporarily, like forest fires?
Yes, we might sometimes need to restrict flight activities on a temporary basis. What should we call something like that?
We could call it a temporary flight restriction.
We can't rely on sectional charts for these, since we wouldn't know where to put them when we publish the chart. How will people find out about them?
We can publish them in the NOTAM system. The NOTAM will indicate the affected region and what the rules are for operating in that region. Flight service stations will be the official source of information, but we should also use other ways to disseminate this information, like ForeFlight or other electronic flight bag software.
Are there any other rules with exceptions and exceptions to the exceptions that we need to cover?
No, I think that about covers it. Thank you all for your time today. To summarize the visibility rules, the standard VFR visibility requirement is 3 miles. In Class G airspace during the day below 10,000 feet, this is relaxed to only 1 mile. Above 10,000 feet, it is increased to 5 miles. To summarize the cloud clearance rules, the standard rules is 500 feet below, 1,000 feet above, and 2,000 feet horizontally. In Class Bravo airspace, this is relaxed to clear of clouds because controllers are handling separation. It is also relaxed to clear of clouds in Class G airspace because IFR traffic is unlikely to pop out of a cloud. Above 10,000 feet, it is increased to 1,000 feet below, 1,000 feet above, and a mile horizontally because other airplanes may be going faster. This table summarizes most of the rules we have discussed.